Okay, now let's try to review about complex numbers or one of the applications of complex numbers. So let's say we have here complex numbers z sub 1, z sub 2, z sub 3. Let our z sub 1 equals 2 plus 2i, our z sub 2 equals 3 minus 4i, our z sub 3 equals negative square root of 3 plus I. There are a lot of questions that could be generated from these given examples. You may be asked to change this Cartesian or rectangular form into modulus argument or polar form or in Euler's form. So that's one. Another thing is you may be asked to graph this in the Argand diagram, okay? Or you may be, or this can be used as a way to solve problems in geometry. So I will not dwell on the first two because I think they are a lot easier topics to review. Okay, you can do that on your own. So let's say this Z1, okay, let this be yung C sub 1, C sub 2, and C sub 3, the vertices, okay, vertices of a triangle. So the question that could pop up is you have to find either perimeter or probably the area. In this problem, I'd like you to find the area. So first thing first, we need to, because it's area, we need to, since these are vertices of a triangle, we can um, plot this in the diagram. So 2, 2, let's have it here. Okay, let that be our C sub 1. I'll just use C sub 1, although you can use 2 plus 2i or the coordinates 2, comma 2. And then 3 negative 4 will be somewhere here probably. Okay, let's call this our C sub 2. And then the negative square root of 3 is around 1.73, so that's closer to 2. So, and then 1. Okay, so these are going to be, wait, I can't see that one. Let me erase this. How do I remove this? It doesn't disappear. Okay, wait. I need to work on this one. I can simply remove this graph. Doesn't change the display. Anyway, let's just leave it at that. So negative 1.73 is around 2 and then 1. So it doesn't write. So somewhere here. Huh? So that's our C sub 3. Let me use a different color. So if we're going to draw a line along the vertices, usually from here to this point, from this point to this one, so we're able to form a triangle. I don't know why I can't remove this one. Let me check on this. I can't remove this. Okay, let me try again. It's taking time, bear with me. I don't know how this one shall be removed. If I have that undo, let me check. It will undo everything. I don't know why that appears. Anyway, let's just go back to where we started. Yeah, it's done now. Okay, so to find the area of a triangle, we can use a formula which you learned in area in high school or in junior high that the area is equal to 1/2 the adjacent sides AB and then sine C. So we need to find we need to find the length that represent the A and B. So probably we can have, we have white color here. I don't think there is a white color here. These are the only colors available. Let us try, I don't know if green will look better here. So let's try to work on this and that region. I just make it yellow. I hope it will not confuse you, but there's really no other color here. So here, from here to this point, and from here to this point, we can form one region of triangle. Okay, and we have another region here. Okay, so yeah. So we get to find the region, then we can perform AB sine C. Let's say we're taking note of this region. We like to take note of this region. Okay, so we need to find the modulus of C1. So you can use your calculator to find the modulus because it's a problem solving. You don't need to do that by hand. So you simply get your calculator, go to vertices and matrices. I don't know, go to complex numbers, number. Wait, let me check again in my calculator. So menu and then second time. So you go to menu and then number, menu, number, complex number tools. So that is your friend here. So let me write that. So that's gonna be any number. You must be very good at using your calculator. Complex number tools. Complex number tools. And you choose what you would like. There are a lot of choices there. In this case, you're going to find the modulus or what we call the magnitude. The modulus, the magnitude. So the magnitude of this is, what's the magnitude of this? 2 square root of 2. So C sub 1, let me write that. The magnitude is 2 square root of 2 and its argument, its theta is equal to pi over 4. You can also check that in your calculator. C sub 2, so you just encode this 3 minus 4i and get a modulus. So the modulus of this is 5 and the argument is negative 0.927. So again, another thing that you must consider is make sure that your calculator is in the correct setting. It is in radian mode. Okay, and then C sub 3, our modulus is 2. So, and our theta there is 2.62. 2.62. I'm not going to discuss everything here so we can have more things to discuss, more topics to discuss. So if this is 2 square root, let me use yellow here. 2 square root of 2, this is 5, and this is 2, and this one is pi over 4, and this one is 0.927. We're not going to add positive and negative because we're taking the sum of these two. So we're dealing with how much is that angle. So we're combining them together. So for the region 1, let's say this is our region 1. So region, let me use red. Region 1 will be 1/2 of 2 square root of 2 times 5 times sine of pi over 4 plus 0.927. Okay, so radian mode again, make sure your calculator is in radian mode. We get also region 2 and region 3. And let's say this is our region 2. So what do we know about this angle? Or maybe we can do this first. Uh, from this one, this is point, wait, this actually is 2.62, right? Let me erase some to give space. So, okay. This one is, wait, 2.62. Wait, on right. So this one is 2.62. So to find this angle, okay, let me do that here. From this point is 2.62, right? But we only need this part. So that will be 2.62 minus, but how much is this? Pi over 4. Pi over 4. So for region 3, region 3. So we have 1/2 of 2 square root of 2 times 2 times sine of what? 2.62 minus pi over 4. Okay, so 2.62 minus pi over 4. Let's just calculate that. 2.62 minus pi over 4. 1.8346. So this is 1.8346 and so on. So we're going to look at our triangle we have here. This is pi over 4 plus 0.927, and this one here is 1.8346. Therefore, for the second region, I already labeled that. We shall have 1/2, and the sides are 2 and 5, and then sine what? You can have it. The whole thing is 360 degrees. So we can have 2 pi, or that equivalent, minus your answers previously, which is pi over 4 plus the total of this 0.927 plus 1.8346. Okay, or instead of 1.8346, you can substitute that with 2.62 minus pi over 4. Then you will be getting an answer here. Let me erase this. I'm not going to write this anymore. So you'll have answer here, also answer here. That will be the total area of that triangle. Okay, I think if you would like to really check with your answers, you can look at, let me check, it's on exercise number 7 in your book. Okay, let me check the reference. So, wait. You can look at the page in your book where I think I've written that somewhere. But this is an exercise number 7, example number 7. I just can't find the link here. I tried to make a notation on that. But anyway, this is for your review. I thought I did that. So it's very similar. This is actually that example. Okay, what's the other thing that could be asked that is similar to this? You may be, let's say, instead of giving these things, okay, wait, instead of giving this, I might give you a polynomial. Let me erase this now. Okay, I might give you a polynomial. Where can I write? On the next page. Instead of So instead of giving you c sub 1 equals something, or c sub 2 equals something, or c sub 3 equals something, since there are three roots here, okay, another thing that would be another another way by which I can test you on how to find the area of triangle using um, complex numbers is I might give you a polynomial equation, okay? And then from polynomial equation, you will find its roots. Of course, the roots will have an imaginary number. So, you know, you're working on polynomial roots, okay? Polynomial roots of complex numbers. So there are there are two kinds of roots that you can have. One that is real and the other is complex. So for sure, you will have to look it up under complex numbers. And by the way, I just remember that when you are when you're working with problems, please take note of the limitations of your answers, or the parameters. Let me call that parameters. Okay, sometimes it will ask you to, let's say that your theta must be between, let's say, between pi and negative pi. So if you draw a diagram, you know this is 0 and pi, this or that. So if you have an answer, let's say your answer here is 7 over 6, 7 over 6 pi. You cannot have this because this is greater than pi. Your maximum must be pi, so that will be 6, right? And then or negative pi. So what you're going to do is to use the reference angle. Reference angle. So review our lesson on reference angle. So if that is 7, 6, what is its reference angle? So if you are given this parameter, then if your answer is 7, 6 pi, it's definitely will not be considered. It will not be considered because you are given the parameters. Another thing is the use of the language or notation, like what else? Notation. Real, okay? Real numbers. It could be any real number. Sometimes there's some more restriction. Real positives. It must be positive. Okay, especially working with equations. And n, you must know it's natural numbers. What else? Q is rational numbers. and then you have z integers, either positive or negative. If there is no sign, then everything goes. But if there's a restriction like z to the negative, then only negative integer is accepted. Okay, so this is this is all we have for today. For this particular lesson, I will be working more on another. I will try to make more uh, videos for your review. Something that you can. It's just like reviewing your old notes. Okay, but I know this is not enough, but this might help you. So if you want to be updated on this, you can go back to my YouTube and then find out if there are new videos uploaded. Anyway, your test is still on Tuesday. I still have time to. You still have time to review on Monday. Okay, goodbye for now.